Okay, my name is Nashwani Bitalu Halim. This is my part, is literature review. This session covers the basic idea behind the project and provide summary. Okay. Research for complete. Okay, Simulink. First we use MATLAB because it offers simulation automatic code generation, system level design, continuous testing and verification of embedded system. Okay. Based on the waveform time statistic, PQ disturbance, which is divided by two groups, which steady state disturbance and non-necessary disturbance. Okay. Also, it's sometimes regarded by business owner. Power quality has a substantial impact on the entire operation of enterprise. This factor is significant for both the producer and user of potentially dangerous equipment. User can determine if equipment failures are caused by interference or internal problem by adapting monitoring system, and producer must be aware of the intended performance of their code and their goods. It is possible to use MATLAB to model a power system at disturbance and evaluate and see how they affect the system. Alright, that's all for me.
Now I will explain about our methodology. In methodology, the power system will focus on the dynamics of the power system when a disruption occurs. So the loss of synchronism that occurs when a power system is disrupted by a specific substance is a basic definition for power system instability. So there are three types in this experiment. Three types of stabilities in power system, which is the stability in a steady state, the transient stability, and dynamic stability. So in this experiment, we use the MATLAB software as it provides many tools that can be used for data analysis and visualization. So the MATLAB Simulink is used to create the model for this experiment. And then the end result we will obtain when we do the simulation. So this is the flowchart for our experiment. So firstly, we identify the objective and scope of the experiment, and then we conduct some research about power system stability. Then we design a two-area power system in the MATLAB Simulink, and then we set the parameter for each block, referring to the lab sheet, and then we analyze the simulation based on the graph that we will be obtained. And if the requirement is fulfilled, then we will record the result and analyze the result that we have obtained. So that is for the methodology.
In conclusion, power system stability analysis using simulation of power system reaction is a crucial technique for comprehending and ensuring power system ability. Creating mathematical models of the power system's element and dynamics such as its generator, transformers, transmission lines and loads is necessary to simulate power system reaction. To preserve the stability of resilience of the power system, simulation also helps in studying the consequences of disruption and developing solutions to lessen those effects. To preserve the stability of the resilience of the power system, simulation also helps in studying the consequences of disruption and developing solutions to lessen those effects. By giving a thorough understanding of the dynamics behavior of power system, it facilitates the identification of stability problem and the development of efficient control method. Utilizing simulation techniques can strengthen the stability of power systems, ensuring the secure and effective operation of power grids. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurlana Balkis binti Hairi. I will present about the problem number 1 and also problem number 5, which is the sudden large increment of load at bus 7 and also the temporary bolted 3-phase bulb at bus 8. Okay. As you can see, this is the part of the circuit at bus 7, which is in here. Okay, this is the graph that we get from the steady state condition, and then this is after that I will adding the another load and the circuit breaker. Okay, we add the loads for 50% of the load increment, which the active power is 483.5 megawatt, and the inductive reactive power I set to 50 megavar, and the capacitive reactive power I set to 100 megavar. So for the circuit breaker, we set open at the initial status, and the switching time we set to 20 seconds. So when the 20 seconds, we can see at the graph, it will happen the disturbance at there. Okay, as you can see, this is the graph after I've run the simulation. Okay, as you can see, at 20 seconds, there are disturbance in here due to sudden increment of the load at bus 7. Okay, next is the problem of the temporary bolted three-phase fault at bus 8. Okay, this is the circuit diagram when there is no fault at bus 8 also. Okay, and then this is the steady state condition of the graph before the presence of the faults. Okay, next. Next, I put the fault at bus X, which is the initial status I set to 1, because the 1 represent of there is a fault, and then the switching time I put 1 until 2 seconds. Okay, because it is just a temporary, so I set to 1 until 2. Okay, next, this is the graph that I got. As we can see, compared to the steady state condition, there's disturbance in here due to the temporary three-phase fault at bus 8. Okay, that's it from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nashuhani binti Abdul Halim, AE100045, and I will present about the simulating at second situation, second number, which is sudden decrement at bus 7. Okay, I choose area for bus 7 at area 1. Sorry, lab. Okay, I choose this. We suggested to decrease around 20%. Okay, active power, we decrease 20%. Decrease 67690000. Oh, 97 Okay, and apply. And we run the simulation. I have looked the now we can see at data graph like this at power and voltage. Okay,
Present about the sudden large increment in bus 9. So in area 2 we can search for bus 9, and this is where we will change the active power here, which is 256.2651 E6. So we apply, then we can run the software. So now we can check the graph here. So this is the output for the disturbance 3 at bus 9.
Hello and Assalamualaikum. I am Muhammad Nur Fazali bin Adnan and my matrix number is AE190060. Now I will explain about the simulation for disturbance 4, which is the sudden large decrement of load at bus 9. So as you can see in the simulation, this is bus 9 with 1767 megawatt. So the decrease is 50%, which is divided by 2. So after that, after we run the simulation, we will get this graph. So based on this graph, we can see that the initial 0 to 3, the system becomes so unstable, and after 3 seconds, the system slightly becomes stable for 10 seconds and then become slightly stable.
Continue to 6, which is permanently both three-phase fault at bus 8. Okay. So for this situation, I need to setting at fault at three-phase fault, and I need to change to 020. Okay. And you can see the graph after this. At first graph is unstable because this has, and the third graph also have a not continuous graph because this have a stability unstable. Okay, that's all for me.
Now I am going to present about the for disturbance 7, which is temporary voltage 3-phase fault at bus 5. So first we will go for the block parameter BRK1, then we change the switching time to 1.5 to, then we apply, then we run the simulation. And we can get the graph for the fault. So this is the graph for the type of disturbance for temporary voltage 3-phase fault at bus 5. So that's all from me. Thank you.
Hello and Assalamualaikum. Now I will present to you the simulation for disturbance 8, which is the temporary voltage 3-phase fault at bus 11. As you can see, the bus 11 is BRK2 which is we can change the parameter into 1 and 2, which the fault will occur between 1 second and 2 seconds. So after we run this program, we will get this graph. So based on this graph, we can see that 0 second until 1 second, the system is stable, and between 1 second and 2 seconds, the system becomes unstable, and after 2 seconds, the system gradually becomes stable. This is due to the temporary voltage fault that occur at bus 11.